All right. So I showed you how to factor these things. All right. I actually didn't show you guys how to do these first two types of problems, greatest common factors and differences of squares pattern. I showed you the difference of squared pattern, so I'm gonna count on you for that one. Let's do a few of these. I guarantee you I'm gonna give you these as homework problems. So maybe it would be good for us to sit down and maybe do some of these homework problems. So this is a bonus video. I know it's probably gonna be long, and you know what? I don't even think I'm gonna give you points for this. Because I'm giving you the homework answers. Alright? Alright, check this out. 15x or plus 20. How do I factor that? How do I factor that? Is there a number? First question you have to ask yourself.
5.
What do you mean 5? You're absolutely right. You didn't even let me finish my question. What is it? What do you mean 5?
5 fits perfectly in 15.
The factoring type we're going to be doing in this case is called greatest common factor. We're just pulling out as much as we can, simplifying it before we have to do that crazy, double parentheses thing. I'm going to pull out a 5. If I pull 5 out of 15x, what am I left with? No. By pulling 5 out, I mean dividing 3x. If I pull a 5 out of here, I'm left with 4. Good. That's factored. We good? Let's try this hard-looking one. 18m squared np squared plus 36m squared n squared p. What? That's right there. It's right there. I know you're all worried. You're all freaking out. All right. What number can I pull out of both of them? What number can I pull out of both of those things?
2.
I could pull out a 2. I can do even better than that. I could pull out a 6. I can get even better than that. You see what I mean? Like if I pull out a 6, right, I would end up with 18, so that would be 3 and 6, right? That tells me I didn't do enough. I didn't pull that enough.
You could pull 18 out.
I can pull out an 18. Yeah, I could pull out an 18. That is the greatest common factor, right? 18 nicely goes into 18. 18 also nicely goes into 36. You guys are freaking out about all these letters, right? You're looking at this like, what the heck is this? I'll tell you what, the letters are actually the easiest part. There are 2 m's in this part over here. There are 2 m's over here. What is the maximum number of m's I can pull out? What is the maximum number of m's that they have in common? 2. So I'll pull out an m squared. Okay. There's 1 n in this first term. There's 2 n's in the second term. What is the maximum number of n's that are in common? Just one of them. I can't pull out 2 n's out of here because there isn't 2 n's out of here. So the most I can pull out is just 1 n. There are 2 n's, or there are 2 p's in the first term. See, this whole thing is a term. There's 2 p's in there, right? There's only 1 p in this one. What is the maximum number of p's I can pull out? 1 of them. So, for this first one, if I pull out an 18, what am I left with? I'm left with just the number 1, right? If I pull out 2 m's, no m's. If I pull out 1 n, if I pull out 1 p, so that's just p. Plus, all right, if I pull out an 18 out of here, what am I left with? 2, okay. If I pull out 2 m's, none. What about 1 n? I'm left with 1 left over. What about 1 p? None. That's my factored form. It's not that bad. It looks crazy. It looks scary. Not that bad. Got it? All right. I'm gonna do this problem, x squared minus 36, and I'm gonna ask Jordan to do it do this because I taught him how to do this. Whether or not he remembers from an hour ago is a different question. How do you factor that? I told Jordan, I said, I want you to memorize a list of numbers, and I put the list of numbers over here. Not memorize them, but at least be familiar with them. These numbers over here. Can you look at those numbers and tell me if you think, if you see any of those as special?
36.
36 is special, you're right. What makes those numbers special? I'll give you a hint. These are called perfect squares. 36 is a perfect square because it's 6 times 6. 49, 64, 81. You learned these, right? I mean, you didn't even learn these. Someone probably didn't even teach them to you. You just probably got good at this when you were memorizing your multiplication table back in 4th grade. Right? Unless you didn't memorize your multiplication table and you've never seen these numbers before in your life. I gotta make you some flashcards, dude, and then my son can quiz you if you want.
Yeah. I wouldn't mind.
Alright. So look, check this out. If you see a perfect square, 36, 169 is also a perfect square. That's 13 times 13. 30 is not a perfect square, by the way. 25 is, right? Is 49 a perfect square? Yeah, what is it? 7 times 7. What about 64? Is 64 a perfect square? Yeah, good. And there's a minus in between these perfect squares. So I'm dealing with a perfect square. This perfect square is 1, and this perfect square is 36. 1 is also a perfect square. 1 times 1 is 1. So the number in front of here, which you don't see, but I didn't write, is 1x squared plus or minus 36. If you see two perfect squares and a minus in between them, there's a trick that we can use. It's a formula that we memorize. Do you know the formula? All right. I'll tell you what. I'm going to rewrite this just a little bit. X squared plus 0x minus 36. Let's do this like we're regular factoring. So I've got an x here and an x here. I want to factor this triangle. What numbers can I use? Oh, by the way, what is going to go in there? Plus plus, minus minus, plus minus. Jordan obviously doesn't remember this. Well, I mean, you would have told me the answer by then. No. All right, so what goes in there? It's not minus minus, I agree. It's not plus plus, so that means it's got to be a plus minus or minus plus. Right? Now, what numbers can I choose? They need to be two numbers that multiply out to be 36, but also add to be 0. 2 and what? 18? 2 and 18 multiply out to be 36. I agree with you. They don't add to be 0. 6 and 6. Perfect. Good job. No, you said 2 and 18. All right. What about this one? Let's try this one. X squared minus 169. Okay. X. I know it's going to be a plus minus. What multiplies out to be 169, but adds up to be 0? I'll give you a hint. Comes after 12. 13, perfect. Well, what can you tell me about like this thing right here? What's interesting about these two kinds of solutions? Jordan, you got to tell me this one. What's interesting about the solutions that I came up with? They're the same numbers, but look at these solutions that I have. Look at these solutions that I have. What can you tell me about that solution that makes it interesting? I went over this with you, Jordan. You cannot have a memory of like an hour.
I can't.
No, not in my class. It's not allowed. Look. There, it's right here. It's the same number. What's different? Yeah, you're right. You're right. And that's what he said too. But what else? It's different symbols. Plus and minus. Plus and minus and plus. Plus and minus. And that will give you these perfect squares. I'll tell you what. Watch the video on perfect squares. I'm not even going to cover that with you.